session. Good afternoon, everyone. Welcome to the talk about the new cluster, MLC cluster computing seminar. And it's my honor to have Paul Rains to give us this talk here today. And I don't think I need to introduce Paul further because everyone probably have been helped by him over the years. And Paul joined Martinos Center almost 21 years ago. So he definitely knows a lot about the topic. So without further ado, let's Paul take it away.
Thank you. Hello, everybody. So yes, I'm talking today about our new MLSC compute cluster, which is hopefully going to be replacing Launchpad, but we're going to have some overlap. So Launchpad will probably still stay around for a while, to the end of the year around that. So let's go ahead and get started on how to use this. Just one thing I'll say at the beginning, Launchpad is, for those who don't know, is like over 10 years old now. The nodes in it are over 10 years old, so they are really old. So it was definitely time to do something else. And so the MLSC compute cluster, what is it? We got this cluster from a 2.2 million, well, it was part of a larger MLSC grant, of which 2.2 million was for computational infrastructure. The actual equipment is located at the Marlborough Data Center, and it consists of the actual computational servers, which are the main part, which we'll get into more detail later. These include 4 NVIDIA A100 DGX boxes. They're their latest sort of supercomputer from NVIDIA. They consist also of these 8 systems from Exact, which contain NVIDIA RTX cards, some 6,000, some 8,000s. And then we have 32 Dell non-GPU nodes, which is basically what's the equivalent of Launchpad is. There's no GPU there. Holding all this together, the network infrastructure is all one, consists of these 100 gigabit switches that I list here. The Dells actually are going to be connected at 25 gigabit, so one port is actually split into 4 for those. But the big GPU boxes are connected at either at least 100 gigabit, or in the case of the GXs, you'll see that they're connected at even more than that. And the VAST also has more connections. So this is huge network bandwidth going on here compared to most people only have 1 gigabit. And sometimes if you're in an old part of the building, you only have 100 megabit going to your workstation. Also, as part of this purchase, we got a huge, some really high performance storage from a place called VAST. It's a 1.3 petabyte, and it is all flash, no magnetic media. This is ultra fast. And I'll talk about more of that later. And then the other parts of the infrastructure that you have to get, of course, racks, KVM, PDU, cables, stuff like that. And this done here, I'll show that again at the end. That's the website everybody who's been dealing with MLS structures pointed to. Let me just jump out of here real quick to show you. I was talking about the racks. There's 3 racks, and you can see all that infrastructure right here, right out there. But then here is the web page I want everybody to go to when they start using the MLSC. So you should be seeing this when you get your account. All right, so let's go back and let's talk about how you do that. So more details on the actual compute servers. Like I said, we have 4 of the NVIDIA A100 DGXs. Each of these have 8 A100, these new, their latest enterprise model A100 GPUs in it. Each of those cards have 40 gigabytes of RAM on them. They're all connected together by something called this NVLink switch inside, which is really high bandwidth in between the GPUs if anybody does any inter-GPU communication. One interesting thing about them is the CPUs are actually AMD and not Intel, AMD EPYC. That has some you have to think about that sometimes if you have binaries that were compiled with very specific Xeon optimizations, then they might not work on these AMDs. You'll get bus error or something if you try to run those executables. So, but very few people have compiled their binaries such that they will only run on Xeons. But that's just something you need to be aware of. These things have a terabyte of RAM each, and as I mentioned before, they have a whole lot of 100 gigabit ports. In fact, the way these were designed is they have a 100 gigabit port dedicated to each GPU, so that even between servers you can get really high bandwidth if you're doing stuff like that. And also 2 extra ports for doing to a storage or just your normal corporate network. They also have some local storage on them too, but that's all flash and SSD. And then we have these 8 servers from a place called Exact, which have these RTX cards in them. We have 2 servers that have 8 RTX 6000s in them. We have 5 servers that have 10 RTX 8000s in them. And then we have 1 server that we're sort of growing. As we get donations or something, we'll add more RTX to it. And these are running Xeons. They have 1.5 terabytes of RAM, so they have actually more RAM than the PGX servers. They have 200 gig ports, but we're really only using 1 of them. And then they also have their local disk is all SSD. Then we have the 30 Dell servers with no GPU, so this is all for just CPU only work. And they have 2 Xeon Silvers in them. They only have 384 gigabytes of RAM each. And they have 25 gig network to the switches. And then we have 2 of these Dells that are very similar, except they have a local RAID on each for database information that are used. One is the server that you log into when you SSH to MLSC. That's the login server, and then we have a control server which actually processes and controls the Slurm batch queuing system. All right. Other things about it. So CentOS 8 is what's running on the Dells and those RTX servers, but the NVIDIA insists Ubuntu be run on the DGX server. So that's another thing you have to be aware of if you're running jobs that are going to the DGX servers, is that it's running Ubuntu. And so that means some things are slightly different, especially one issue that's come up that I got to figure out how to solve, in that CentOS 8, they have the /bin and the /user bin directories are the same directory. One just points to the other. So it just puts one in your path. But then when you log into Ubuntu, they're still separate. And then if from the login server, your path still only has the one in it, then it misses something on Ubuntu. And I got to figure out what we're going to do about that. So there are some issues you might have to run into because of this Ubuntu issue. One thing thinking about is setting up a Ubuntu server that people can log in just to test things on. But so that might be down the line pretty soon. Okay, as been mentioned before, this job management system being used is Slurm. Part of the reasons for going to Slurm and not Torque, one big reason, which I didn't list here, is that actual support, especially for the Maui scheduler part of Torque, is essentially non-existent anymore. The outfit there has pretty much gone all enterprise and want you to pay, whereas this is more open source, and definitely you'll find a lot more people using Slurm out there now, especially like Harvard Med Schools using Slurm, BU, Harvard FAST. It seems to handle GPU resource allocation better. It has a lot of better accounting tools. And the fair share priority system is something we'll get into more that seems to hopefully handle that priority of who gets to run jobs when better. Other things with their system management, we're doing through Puppet, monitoring through Nagios. This is just general CentOS stuff that you guys don't really need to know about at this point. But The only thing about the software, most of you are familiar with, except for that Singularity. Singularity is something that lets you run Docker containers without having to have a Docker server running itself. There are some issues with that, and I have a page about Singularity, but that's not what this talk's about. It might be for a future talk at some time. All right, so how do we actually use this cluster? All right. Well, the first thing you need to do is to get access. And for that, your PI needs to establish a Slurm group account for their lab. And so what is this group account? Well, the group account is on Launchpad is, for those people who've been using Launchpad so far, there is no sense of group or lab at all there. All users are sort of just equal, and there's no tracking of what a job is actually for, except for that user. So you can only guess, but users can be members of multiple labs, or labs can have multiple large projects going on. You don't know what their job's doing. So one thing we're doing this for is just to have better sort of analytics and statistics about what certain things are being used for on this cluster. So to establish the Slurm group account, the PI sends us a request to help. At the same time, we can also request volume for VAST storage, which again, I'll have a slide on the VAST storage later. So they just need to request the account, and they can tell us what users to put on the account to then if they want to do that. But any account that's going to use the system still needs to be a full account. So that's an account where we do charge that monthly fee to have the full account. So for PI, PI, if somebody doesn't already have a Martinos account, this is how you get it. But I'm pretty sure everybody here on this seminar already has one. So the other thing is, if your PR has established a Slurm account, but they didn't already ask for your account to be put in that Slurm group, you just need to request that. I just need to request that from us. We'll put you in there. You can be in multiple Slurm groups. And then it's also mandatory to still be in the batch users mailing list where if you're going to be submitting jobs. And then once you've got access, you just SSH to MLSC.NMR. Should just be able to just SSH MLSC from any other CentOS workstation in the Martinos domain. And from there, you can submit jobs. So now let's see how you do that. But first of all, let's talk a little bit about Slurm terminology, because it's different than with PBS Pork. I've already just mentioned the Slurm group account, which is just a group of directors working on the same projects. Basically, lab, but a lab could have multiple group accounts if they're really large and it needs demonstrated. And it also is what the fair share priority system, which we'll talk about later, is really based on. It's based on these group accounts and not individual users. So what other terminology? Job, that's everybody's familiar with that. Same from Torque as the submission of an analysis that defines the resource allocations needed. Here's where it gets different. Partition. So partition is what is called a queue in PBS Torque, but they're called partitions here. And so like when you hear the word queue in Slurm, that's referring only to the job submission queue, whose job's going to run next, things like that. The partition is that. Node, that's the same. That's one of those physical servers that we just talked about, the A100 DGX, the RTX boxes, the Dell R4 for the non-GPU jobs. Resources are memory, time, GPU, cores, etc., what's required for the job. And this is going to be more important to think about here with Slurm than it was with PBS, as they're making them sort of mandatory to run, to really think about what you need more than we did on Launchpad. So there's also this, in Slurm, there's a notion of task, and generally there's just, the vast majority of people, it's just going to be one task per job. So a task and a job are going to be the same thing. But you can't have multiple tasks within a job as sort of an advanced thing. And then CPU and core are kind of the terms that are used almost interchangeably within Slurm, especially because we have hyperthreading turned off on all our nodes. In case that's something you know about. That basically means that CPU and core are the same for us. What you normally think of as a physical CPU are really called sockets in Slurm. All right, so I told you that I was really going to have people think harder about their resources than they did in than they did on Launchpad, because in Launchpad, if you just submit without setting anything, you get like one core with 7 gigs of RAM, and there's no time limit. I think the default time is like 64 hours. I can't remember now on Launchpad. But it's going to be a lot smaller here because I want people to actually think about it. So the default, if you don't specify it, is only 10 gig of memory, and it's only 4 hours of time. So let's talk more about how you actually submit. Oh, I'm sorry, still not there. All right, let me just give you a resource overview. This again sort of shows what you have, but like I said, when you're thinking about memory, how much memory you're going to ask for, especially you need to think about, well, I'm submitting to the gels, which the name of that partition is basic. Then, if I'm asking for 2 cores and I know that there's 384, I could ask for, do the quick math in my head. I think it's like 16 gig per core there, so you could ask for 32 gig. But is that really what you need? I mean, if you ask for more, then you might run up against resource limit. Have your job queued longer because it's not going to fit. So you got to use this to sort of think about. Basically, you should try to know what your jobs are and how much memory they really use, and then only ask for that amount of memory. And know if your jobs are multi-threaded, and thinking about how you're submitting, and how, the less you ask for, the more likely it is to run sooner. You can divide your jobs up, then asking for less cores can be better, but you have still want to ask for enough what you need. So the thing is, I can't know your job. You guys got to know your jobs, and you got to know what you need to ask for. One other thing I should talk about is there is a local scratch space on each node at just /scratch. We have the tempdir directory, which is the most common thing that various software libraries and stuff use to know where to write. That usually is /temp, but we set it to /scratch. But some programs don't abide by that, and we'll still try to write to /temp, and you need to be aware of that and try to figure out how you get them to write to /scratch for that. Also, in the future, we want to set up a scheme where there'll be a per job scratch directory, so if your job is job 99, there'll be a /scratch 99, and that's what tempdir will be set to, and that's what you should use, and that will be deleted as soon as the job's over. As it is, we'll just cleaning files every 7 days on the scratch space. Also, there is a scratch space we now have on the VAST storage of VAST Scratch that everybody can use, and that is accessible from all nodes in case you have jobs that are running across nodes that need to share a scratch space. Okay, now we're actually at submitting. Everybody on Launchpad is familiar probably with the PB submit script that's written, and this is sort of the equivalent of that on the Slurm side, but it's not totally equivalent. The options are very different. You can't just submit like you were submitting with PB submit and just change the name to job submit. The options are all different. You have to learn it. And it's a wrapper around the native SBatch tool for Slurm, which we'll show in the next slide about using that. So that's sort of replacing QSub. Specifying the memory and the time limits are mandatory when you use job submit, as well as specifying the partition and the Slurm group account. And when you give the command to run at the end, you don't have to put quotes around it like we were doing with PB submit. So you'll see an example down here in a minute. But to see the full help and all the options available, just run job submit with the -H option, and you'll get that. This just shows how to change. So like on Launchpad, everything went under /PBS in the username. Here they're going to go under /cluster/batch in your username, and the output will go into files that look like this. So here's an example of submitting. So here we're submitting to these 2 partitions. You can submit, if you submit a job and you list comma-separated multiple partitions, it'll just run on the first partition it finds available. This is the Slurm account. So, for example, here is system in, which is the Slurm account I'm in. It's asking for 120 gigs of memory. It's asking for 1 day and 12 hours. It's asking for 3 cores and 1 GPU. And it will mail you at the end of the job or if it fails. And then this, not in quotes, this is just the job that's being submitted. All right, so I saw sbatch is actually the native Slurm command, the sort of the equivalent of qsub. And with this, you can specify these the options either in a, well, one thing with sbatch is you always have to submit a script. There's actually a / wrap option to sbatch you can use to sort of create a script on the fly with a command. You give that option, sort of like you were putting the command in quotes with pd submit command before or qsub before, but it's better, I think, and it documents what you're doing better if you create a script like this and put all the options in them anyway. So here's an example of that, but you can do both. You can have options specified in the script that's submitted. So this script is testjob.sh. Then you can also still give options on the command line. And so if you just do a man sbatch, you'll see all the various things that go on, including the more advanced things like setting dependencies, this -- dependency for like after OK on a previous job if you don't want job to run until previous job has successfully run. All right, and you can do interactive jobs. We're allowing that, and that's done with this srun command, that pty option. But it's important that if you do this, that you actually actively use those shells and keep using them, and don't just leave them. Get yourself an interactive shell on one of the nodes and just leave it idle overnight, where people are waiting to be able to use that CPU. And if you do that, the fair share weighting, as you'll see, will still apply to you over that clock time. It doesn't use the CPU time; it uses the clock time. So your idle time will affect your future job priority just as much as the time spent using 100% of that CPU or GPU. If you need to run X GUI apps this way from a job, you need to include this option. And so here's an example submitting using example interactive job submission using srun. The main issue is here is that -pty followed by the command, which will usually just be the shell you want to run. So bin bash or those old timers bin tcsh. Okay, so the other sort of tools from Slurm that you'll learn to use, SQ is sort of like QStat, where you'll show current queue status showing running and pending jobs. SInfo gives you an overview of the status of the jobs. You guys probably won't need to use it that much. That's mainly what I use to see what nodes are up or down or what queues are in trouble. scontrol gives you more details on a running job or node. So get full details on a job, kind of like the qstat-f from before is scontrol show job and the number. Share we'll get into more detail when we talk about fair share. Account is how you see info on your finished jobs you've run in the past. So this, for instance, shows all the jobs run since that date. It gives me these stats on them. Cancel to cancel a running job. Cancel no longer need. Attach to see the standard out and standard error of a running job. Prio to show priority calculations. All commands have man pages, like man sq. And for those people who need to develop or compile programs and you don't have your own hardware, you could use one of those interactive jobs in a pinch. And, there actually is that came with Slurm. Some of the PBS tort commands, there's actually a qsub, which basically is a wrapper to try to translate qsub stuff to sbatch, but not all the options exist. For instance, the -l option in qsub that the reason most people use qsub instead of pb submit doesn't actually exist in the qsub that came with Slurm. So you'll definitely have to learn to just use sbatch. All right. Let's talk about the fair share priority system. This is very complex, and again, this is something I really need people to start using the system and actually get jobs sort of backed up and waiting for resources to see how this works. But, the basic concept is that each of these Slurm group accounts gets the same 200 raw shares. Now that number 200 is essentially an arbitrary number. I could easily just made everybody have 500, but it's just big enough to give granularity to the calculations that are made. What matters is just the relative values compared to the group, but since everybody's getting the same 200, that's sort of immaterial. So, I mean, we're still working on policies, though, on that. So, I mean, we may, when certain groups have, like, well-defined short-term deadlines and they really need get some jobs through, we might temporarily up their share, so they will get base priority bigger than other groups. But for the most part, each group is at the same priority. So the way job priority will work in the submission queue, it'll be based on your group account's share weighted by a usage factor. So, I mean, the basic concept is the more heavily you're using the system, your weight becomes heavier on your share, so your factor on multiplier for your priority makes things go down. So that lets people who haven't run as many jobs as yet get their jobs in possibly sooner. So each resource has a weight that you ask for, and those and the weights of resources that are slower are different. So a A100 GPU has a higher weight than the RTX 1000, which has a higher weight than the RTX 6000 according to CPUs, and the same goes for the GPUs. All the memories the same on all systems. Also, there is older the usage, its weight decreases in time for that particular job. So that there's a half-life factor applied of a month currently, but that's another sort of tuning factor I might tune depending on how things go. But that basically, with the half-life factor of a month, that means a job you ran a month ago will weigh down your fair share half as much as an equivalent job you just ran today. So the final fair share factor for some group is normalized to be between 1 and 0, with 1 meaning your account has essentially run nothing recently, and 0 meaning you basically have no shares left. Your account will only have jobs run when there are nodes free, and no other accounts have jobs that with priority that are waiting. So this share command I mentioned before is how you sort of check your share. So here's an example where I've ran it, and I've just to fit it on the screen, I just put a few of the groups up there, and I've cut some of the columns I didn't need to show. So like here's the accounts. Everybody, like I said, has a default raw share of 200. Normalized so that they all add up to 1. Again, this doesn't all add up to 1 because I'm not showing all the groups. You don't really need to worry about this column anyway. Raw usage is more interesting. So the raw usage is basically how much is your weight, is how much usage weight you have right now, and the bigger the number, the more weight, which means it's going to count against you. So you see here, FSDev has the largest. No, I'm sorry, LCN has the largest number at this point here. And this basically, that's just essentially the normalized usage. So don't worry about that. I need to show that column really. But the fair share is where the factor comes in. So as you see, those people who have had 0 usage right now still have a fair share of 1, whereas those with the most usage have the lower multiplier down here. Those very little usage are still very close to 1 from when this was run. Okay. All right. So, oops. All right. So more on the VAST storage. This this is high performance storage, as I mentioned, it's all flash, and so it's going to be the highest performance storage to use from the cluster itself. If your jobs are really I/O bound. If they're not I/O bound, then using the normal Dell storage under /cluster should be fine. Most people, although if your jobs are really front loaded on their I/O, you might want to stagger your submissions of those jobs so they're not all trying to hit your cluster volume at the same time. But anyway, like I said, we've got this vast storage. It's hugely expensive, and it's not something that we're going to be able to easily just add to as we need more. So this 1.3 petabytes raw, which is really about 1 petabytes usable, one is really going to be all we're going to have probably for a long time. So in that case, what we've done is we're going to have to limit per lab how much each lab can get. And so for right now, we set that limit at 10 terabytes, but that might go up on a per lab basis. Also on a case-by-case basis per lab, if it's showing that, you know, our big labs are demonstrate they need more space, we probably will accommodate that. And so because of this limit, even though it's a much better storage, we're still charging the same price. Because essentially, that's almost more of a red tape reason, dealing with trying to get new types of charges in the core is just a huge hassle. And again, like I said, this ultra high performance, but that's only over NFS to the cluster nodes, because that's all within that 100 gigabit network switch. Once you're outside that, you have to go to your workstation. Then that has probably only has a 1 gigabit or worse connection. So it's still actually going to perform better even there than the Dell storage, because the Dell storage, most of the Dell storage systems are also on that 1 gigabit. So when they're hit by multiple users, then that's where the bottleneck is. Whereas when the VAST is hit by multiple users, it still has that 100 gigabit bandwidth it can share over all those users. There is SMB CIFS. Sorry about that. There is SMB CIFS access, which basically means Mac and Windows access to the VAST available, but that's done through a gateway proxy server. So that's not high performance, because that all goes through the same box. It's not over the multiple VAST servers itself. And we do, and each of these volumes will get a weekly mirror backup, just like we do for the Dell storage. In fact, that backup happens to be disk-to-disk mirroring to that Dell storage. And in the future, we're looking at doing things like snapshots and analytics on this. Okay, and that's basically that. Maybe I'll just open up for questions right now.
Yeah, there are a few questions in the Q&A box.
Okay, let me take a look here. Oh, what's stopping me from converting Dell and RTX servers to Ubuntu as well? Basically, we've been Red Hat, CentOS shop here, and that's where all our expertise is, right? In the group with me. So that's what I'm most comfortable with, and that's where we have lots of scripts and other tools that we use that know how to do. I'm developing these tools to work with Ubuntu as well, and eventually I might have option for Ubuntu on workstations if that's what users want. But there's definitely, I don't think we'll do a mass conversion of everything. I don't think that's necessarily what people want either. They just have to convert for when they don't see an advantage to that. But when there's a mixed environment, there's things you have to be aware of that are different between the two, and that can break things if you're not being careful. All right, any other questions? Let's see.
Yeah, there are a few questions in the Q&A box.
Oh, in the QA box. Let me see.
Yeah, it's to the right next to the raise hand.
Here we go. All right. What are what about IPython notebooks in interactive mode? We need port forwarding. At this point, yes, you still need port forwarding. We're still, for security purposes, and because of compliance with partners' Linux rules, we are running the firewall on all these systems. So, the port wouldn't be open. I mean, it's possible that I could just open a certain range of ports and you just have to make sure you use that one, but then I'm not sure how, there would be conflict between two users who get the same node, want to run the same Python notebook, and then they conflict on that port. That could be an issue. I'm not really sure how we would handle that. But nothing prevents you from doing that through port forwarding yourself if you still want to do it, just like I guess you can do it on Launchpad. Okay. Let's see. Oh, do I need to... Okay, let's see. Next question is, can we mount drives on local machines inside Martinos GPU network on the cluster? If yes, how? What is the time lag reading and writing on mounted drives and on the VAST? Okay. I'm a little curious, not sure what you mean by local machines. I mean, all the nodes, just like on Launchpad, you should be able to see, the normal /space and /CentOS volumes. But if you're asking if you can mount from systems outside the Martinos domain or from like your personal systems, that is not supported. So you would have to copy to Scratch or other space first, or you could do that. Now, as far as the time lag reading, writing on mounted drives and on VAST, I mean, VAST is actually just NFS mounted on the systems, just like from the other Dell systems or your workstation. It's just that it's just so much faster and more efficient at it. The time lag to Marlboro should not be noticeable for that type of IO. It's mainly going to be the bottleneck of like the 1 gig connection to your workstation or even to some of the Dell servers, especially when you have multiple jobs running and they're all IO bound. Okay, let's see. Is the cost of using the MLS server $17 per month per lab, or is it per user? That's your per user account, and that's not specific to the MLS server. This is just what we do for having a login for any of our Linux systems. All right. Must all jobs run in containers under Singularity, and where should these images be stored? Is there a plan to host a registry for these? No, we do not have to use Singularity. You can run jobs just like you've been running on Launchpad directly. We're not requiring you run under Singularity. And if you do have images you want to run under Singularity, you'll have to store those images on your own volumes. And certainly if you get it for your lab a VAST volume, that would be an ideal place to put those images. Maybe certain images we might put in a centralized place. In fact, under I actually have some TensorFlow images from the NVIDIA repository that I've put in /cluster/batch/images that we've been testing on the A100s in Singularity and on the RTX boxes. But I don't really have a plan at this point to host an actual registry within our domain. I mean, that is a possibility, is something we might consider later on down the road. All right. Is the charge a flat rate per user per month or calculated based on the actual usage of resources? It's a flat rate. So at this point, there is no plans to do any kind of charging by actual usage of the batch resources.
There's also a question in the chat box.
Okay, let's see. Is there a particular reason for using the new cluster rather than replacing updating Launchpad nodes? Well, I mean, these are replacing the Launchpad nodes essentially, at least from the hardware perspective. You know, from software perspective, that question sort of says why switch from PBS Torque um, to Slurm, and that's part because, like I mentioned at the beginning, that PBS Torque Maui situation has become where I don't think it's just well supported anymore, especially Maui. I actually have to run Maui on Launchpad right now in a loop so that every time it crashes, it restarts itself. It's so bad. Um, and yeah, it's just, and Slurm has just become almost the de facto standard out there that vast majority of high performance computing clusters seem to be using. It's either, you know, they're doing open source, they're either doing Slurm or Grid Engine. And if they're, you know, paying commercial, they're usually running LSF. All right. Any other questions?
I think we've have all questions answered at the point, a moment.
Okay. Well, I mean, here's get a slight demo of what you'll see on the cluster. I'm actually on the head node here, but this will work. So for instance, if you just run SQ by itself, it gives you a good overview of the jobs currently in the system. Let me do that through more. Is that big enough for people to see, or is
Probably better maximize the window, I think.
yeah, I go maximize the window, but it's still going to be small.
Oh, yeah, super small font.
Well, I can. Let me see.
Oh, that's much better.
Yeah. Okay. All right. So we see PD is actually pending. So these are the jobs that are now pending. So we actually have, and these are the jobs running, and you'll see this is essentially the equivalent of a queue stat. But if we want to look at one of these jobs like S control info job equals 39201. That's not info show, sorry. You get the more details. You can see, for instance, that it job asks for one CPU, 7 gigs, so they're sort of carrying that over from their torque days, one node. That's a typical thing. But you can, if you look at the SQ man page, you can find it has a really nice way of changing the format to get different information from. Here's one that shows. Gives me a better idea what's going on because I get to see, you know, what people ask for in each of these jobs. Although I didn't put the state there, did I? So I should have put state in there. Well, anyway, so these are the ones. This is definitely CPU, but obviously these don't have CPU. So that's SQ. SInfo basically is very short because we don't have that many partitions, but you'll see that it shows number of nodes in each of the partitions. So there's RTX 6000, RTX 8000. The state basically means right now that nothing's running on the RTX 6000, so those are totally available right now. RTX 8000s supposedly have both resources available and in use. Same with the basic, when it says allocated, that means they're all allocated now. So all the resources are in use right now. So that's good, and I can see that there was pending ones. The thing that's weird to me, and that I'm trying to figure out now, is why there are pending jobs for the GPUs, even though there's supposedly some available. So as I said, you know, we're at the beginning part of using this cluster, and it's new to you, but it's also new to me. I'm still going through documentation, trying to learn how to use it. So I'm trying to understand that. And so that's an issue that I'm currently looking into right now. And I've submitted a question to the Slurm user mailing list myself, you know, the general one, asking why, what's going on. So we're going to have to go through some growing pains in the beginning here. When a node is down, you'll see down here, just one of the A100s is actually down on purpose because we're doing an experiment. In fact, that's been upgraded to Ubuntu 2004, whereas the ones that are still in queue are still running 1804, and we're doing some experiments on that's running okay. And so what is another command? Oh, that's share. Do I have any good? So this shows all the current sort of fair share of all the labs currently in the system right now, so what they use. So a lot of groups haven't done any work whatsoever yet. So that shows that. What's another command? So I think that basically any requests. Oh, is there particularly? Okay, no. All right. So I mean, let's see. Let me go over actually to the login node. Okay. And I'll come myself. Let me see if I can find. So this is the replacement for /PBS, so you'll see all the users here. I did say I did have some images singularity in there, but these are actually Docker images that were taken from NVIDIA's own NGC registry. And I have somewhere here, as you see, if you run jobs through job submit, you'll get files like these with that's the actual job that got submitted. And then these are like the error and the output from the job. I can show you doing an interactive job maybe here. Although right now it's all pending. So I don't think I can actually run a job that'll get run right now because it's all full. So these are just some examples. Here's another. So yeah, I can submit it to A100. Oh, you're talking about Singularity. There's an example of running one of those images through Singularity. But I'll have more. Let me just remind everybody of this webpage here. And there's the link again. Let's see it. it.martinos.org/MLSC-cluster. And pretty much everything that was in the slides I just showed you is on this page too. To tell you how to submit jobs. So everybody read through all that page. It's not that long before they start using the cluster. You were asking about. This is an old page I'll need to translate over at some point, but this was about using Docker and Singularity. But I'll try to come up with some more information and post that to the batch users mailing list when I can get a better handle on it. So let's see. We got any more questions? Nope. All right. Well then, thank you very much. And,
thank you, Paul.
If you guys have any problems using the system, send email to the batch users list, or you can email help if it's an obvious, more of a obvious infrastructure problem rather than a batch problem. Okay, thank you.
All right. Thank you, Paul, and thank you everyone for attending. And I wish everyone a good weekend. All right. Bye.